So for the start of this unit, we are going to be looking at graphing the first three of your trigonometric functions. And so we're going to start with the sine and cosine function. These functions are a little bit different in that they repeat over and over again. And so that is actually what we call a period. So on the sine function, we actually start here at 0, and a full period is right here. So that's why we actually call it a periodic function. And if you notice, the other side is just a repeat of that pattern. So the sine function is known as a sinusoid. And then the cosine function is actually kind of a horizontal translation of that sine function. If you notice and compare on the x-axis, it starts high where sine starts at 0, 0. But it is literally just that same curve just shifted over. But for cosine, we have a period that does start high, and then it goes and it is over once you get to the top of the hill again. So this is what is known as period. So as long as it takes for the function to start to repeat, and then how deep and how high those hills go, that is what is known as amplitude, which this will be on other parts of the notes, but while we are here, that is what we are talking about. So for period and amplitude, since we are dealing with periodic functions that do repeats, the period is the length of the cycle. Or the length before the graph repeats. So then your amplitude is half the distance between the minimum and maximum. So if we scroll back up to those initial functions, you'll see what I mean now that amplitude, it's actually half that distance because it's pretty much the height to the x-axis or whatever horizontal axis you are using. So if we are given f of x equals a times sine bx, or f of x equals a times cosine bx, then the amplitude is going to be the absolute value of a. So it's going to be that value in front, kind of like a vertical stretch or shrink. And then your period is going to be 2 pi over the absolute value of b. So this is just for sine and cosine. Tangent will be slightly different, but we will talk about that in a little bit. So for number 1, we're going to identify the amplitude and the period of each function. So here on number 1, we actually don't have any number in that A spot. So our amplitude is going to be 1. And then our period is going to be 2 pi, and then that b value is 4, so 2 pi over 4, and that is going to simplify to pi over 2. So that means that it will only take half of a pi in order for this function to repeat. So then on the next function, our amplitude is 7 over 2. And then our period, we don't have anything in place of b. So that's just 1. So it's going to be 2 pi over 1, which is 2 pi. And then on number 3, we do have our amplitude. It's the absolute value of -5, so it's going to be just 5. And then for our period, we have 2 pi over 1/3 because that's our b, which is 2 pi times 3 over 1, which is 6 pi. So that period is actually pretty long. Okay, so let's go ahead and take a look at some graphs. So the first thing that we're going to do is we're going to identify the amplitude and that period. So we're looking at f of x equals 2 sine x. So in a spot we have 2, so our amplitude is 2. That means that our high point is going to be at 2, our low point will be at -2. And then our period, we don't have anything in place of b, so that means that 2 pi is just divided by 1, making our period 2 pi. So some things that I want you to notice about the graphs is that we have everything marked in 1/4 of a pi on the x-axis. So we have 4 blocks, and then we have pi, and then we have another 4 blocks, and we have 2 pi. So look at every block as 1/4 pi. Now on the y-axis, it is in regular numbering. So it goes 1, 2, 3, 4, 5. And all of our graphs will be pretty much the same setup. So for the sine function, you have a pattern. And that is middle, high, middle, low, middle. And that covers 1 repeat. So for our x values, we will start at 0 and we will end at 2 pi. So we can go ahead and mark those because they're both in the middle. So we're at 0 on each of those. Okay, so then to find where we should be for our next middle, we are going to cut 2 pi in half. So half of 2 pi is just pi. So our other middle is at pi. Now for our high, the y value should be 2, and then the low value should be -2. And we are going to be halfway in between 0 and pi. So remember, pi is 4 blocks. So we could look at our high value as 2 blocks. So pi over 2. And so that's halfway in between. So we're going to put pi over 2. We're going to have 2. And then halfway between pi and 2 pi, which is 2 blocks over from pi, is 3 pi over 2. So that means that at 3 pi over 2, we're going to be down at -2. So if you notice, for this period, every 2 blocks, we have a point. And so then we are just going to continue on. So every 2 blocks, And there we go. So we just try to join everything with as good of a curve as we can. And it doesn't have to be perfect. Now, I do not want to see something that looks like a zigzag. I want to see an attempt at curves. But if it is not perfect, then that is not a big deal. Okay, so then for number 5 here, we have 5 times the cosine of 1/2 x. So our amplitude here is 5. And then our period is going to be 2 pi divided by 1/2. And so that's going to be 2 pi times 2. And that equals 4 pi. So for cosine, we do have a different pattern. That starts high and then goes to the middle and then the low and then middle, and then we end at high. So I'm actually going to scoot that over. So we have 0 to 4 pi for this period. So we'll go 0 to 4 pi. And then the low is halfway in between. So half of 4 pi is 2 pi. And then halfway in between 0 and 2 pi is pi. And halfway between 2 pi and 4 pi is 3 pi. So each of these points will be 4 blocks apart. Now, since our amplitude is 5, then we will be up at 5 at the high points, down at -5 at the low points, and of course 0 in the middle. So we will start at 5 for the high. We'll go 4 blocks over and be at 0, and then 4 blocks over and be at -5. So I can't even get a full period in on this side, so I'm still going to go over. So 4 blocks over and be at the middle, and then 4 blocks over I'll be down at -5. So we will go ahead and put in our curve. So then at number 6, we have an amplitude of 3/2. We do have a negative. This is going to flip the pattern because it is a reflection. And then we have a period of 2 pi, and then our b is 4. So our period is actually pi over 2. So it is actually only 2 blocks wide. So for our pattern, we are flipped over. So this is cosine. So instead of high, we are going to be low, middle, high, middle, low. And we have x and y. And so we start at 0. We are going to end at pi over 2. So halfway in the middle of that is pi over 4. And so at these places, we'll be at our low, so we'll be at -3/2. Our high will be a +3/2. And then our low will be a -3/2 again. Now our middles, that's going to be fun because that's pi over 4 is just 1 block. So we're going to have pi over 8. And honestly, with these, we may not even bother to mark the middle. And between pi over 4 and pi over 2, that's in the middle of a block, but that is going to be 3 pi over 8 for my people who like to fill in their whole chart. So pretty much every block we're going to be at a high or a low, but we are starting out at -3/2. So we're going to be there at 0, and then at pi over 4, we're at positive 3 over 2. Of course, the 0 would fall in between. And then back at pi over 2, we're back at the low. So every 2 blocks we have a low. If you want to kind of look at a way to fill this out a little bit differently. And then at every high block, well, those are 2 apart too. So then we will just join these together. So we will just do the best we can. And there we go. Okay. So we have number 7. So this one is also reflected. So we're going to flip the pattern. And our amplitude here is going to be 1 because we have not, we don't have anything in front of our sine function. And then for our period, we have 2 pi, but it is divided by 8 over 3. So we have 2 pi times 3 over 8, which is 6 pi over 8, which reduces to 3 pi over 4. So this is actually 3 blocks wide. So this one's going to be a little interesting. So we are going to make our chart. So this is sine, but it is flipped. So we still have our middle. And then we're going to go middle, low, not 4, low, middle, high, middle. And then we will go ahead and get our points in. So we start at 0, then we go to 3 pi over 4. And halfway in between is 3 pi over 8. So halfway in between that, double that denominator, and you have 3 pi over 16. So this is 3/4 of a block. And then we have 9 pi over 16 here. So this is another kind of weird spot, but I'll show you kind of how to put it together in the end. So let's go ahead and mark out that period. So we're going to hit the middle every 3 blocks to get to the end of our period. And then half of that is a block and a half. So we are going to hit the middle again every block and a half. And then we are going to hit a low first, 3/4 of the way across the block. And then those are each going to be 3 blocks apart. So 1, 2, 3, 1, 2, 3. Going the other way. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then for our high points, that is going to be 3/4 of a block away from the end. So if I look at my end at 3 pi over 4, we're 3/4 of the way in. So we're going to go up to 1. And then those are also 3 apart. So 1, 2, 3. 1, 2, 3. And then 1, 2, 3, 1, 2, 3, 1, 2, 3. And there we go. So it may not be perfect, but we do our best to get it in. And then, our lows, we started out -1. Our high was at 1. The rest were 0. Almost forgot to fill those in. All right, so now let's talk about graphing tangent. So tangent can be a little bit different because you don't have those smooth curves as you go through it. So the tangent function is undefined at certain values. If you remember on your unit circle, we were actually undefined at pi over 2 and at 3 pi over 2. And you will see that here in the parent function for tangent, because actually we have a vertical asymptote here at pi over 2 and then at 3 pi over 2. And we have that asymptote pretty much a pi apart in the parent function. And that's kind of interesting because, well, we thought the periods were 2 pi. Well, that's not so for tangent. For tangent, your period is pi over b instead of 2 pi over b. And so all of your asymptotes are odd, meaning that your function goes in different directions at each asymptote, and that they are multiples of pi over 2 times the absolute value of b. So just like sine and cosine, we do have a pattern that makes graphing this a little bit easier. So for tangent, you don't have to worry about amplitude. You just have to worry about period. So we are going to show the asymptotes on the graph. So we find our period the same way. We look for that b value. And in number 8, we actually don't have it. So their period would be pi over 1 or just pi. So it's 4 blocks wide. So your pattern for tangent is MAM, or middle asymptote middle. And so we are going to start at 0. We're going to end at pi. And then the asymptote is halfway in between at pi over 2. So at 0, we are actually at 0. At pi, we're at 0. But at pi over 2, we have an asymptote. So we're going to go ahead and draw in those asymptotes. So we have our first one at pi over 2. So I am just going to draw that in, and then we would have a middle again. So at 0, we have a middle. At pi, we have a middle. And then at 3 pi over 2, we have a middle. And then going the other way, we have an asymptote at negative pi over 2 and at negative 3 pi over 2. So you see how we have 4 blocks in between these asymptotes because that is how wide our period is. And then at 0, we have a middle. At pi, we have a middle. At 2 pi, we have a middle, negative pi, and then 2 pi. So all of these are also pi apart, so 4 blocks. So then we're going to draw in those fancy curves. So we're going to start from the middle, and we're going to go up as we head towards the asymptote on the right. And then we will curve down as we head towards the asymptote on the left. And so we can just keep repeating this. So I usually do all of my ups all at once, and then I do all of my downs. There we go. There's our tangent graph. So let's go ahead and try another one. I think, yes, this is our last one for today. But we do have a negative on this, so we have to flip the graph. So we'll actually flip the direction of our curves when we are done. Now our period is pi divided by 1/2, which is pi times 2, or 2 pi. So we are starting at MAM, which is middle asymptote middle. So we have x at 0, and then our middle is at 2 pi. So halfway in between is pi. So we'll be at 0 at both of our middles, and then we have that asymptote at pi. So at pi we have the asymptote. At 0 we have a middle. At 2 pi we have a middle. So that means at negative pi we will have an asymptote. And then at negative 2 pi we will have a middle. So if you see that we have 2 pi in between each middle, it'll help you see where that period ends. So then we're going to draw in the curve, but remember that this is flipped because of that negative. So we are going to go down as we go to the right this time, and then up as we go to the left. So we'll go down as we go to the right, and then up as we go to the left, down as we go to the right, and then up as we go to the left.